Welcome to The Explainer. Today, we're tearing down the most extreme aerodynamic anomaly in aviation history. This isn't just about luxury, right? It's a massive case study in what actually happens when practically limitless capital collides head-on with the rigid, unforgiving laws of aerospace physics.
Okay, let's dive into this. $500 million. Seriously, $500 million. To put that into perspective, the base commercial A380 costs roughly $300 million right off the assembly line. That means a staggering $200 million was injected purely into custom aerospace engineering, crazy rare composite materials, and overcoming just massive structural constraints to get this airborne palace off the ground.
Just think about this structural contrast for a second. The Airbus A380 is literally engineered to distribute a payload mass of 800 passengers plus all their cargo and luggage across transoceanic routes. But this project, it stripped away all of that mass transit capacity. They had to completely recalculate the aircraft's center of gravity to balance perfectly for exactly one person, Saudi Prince Al-Waleed bin Talal. So this is the Airbus A380-800 VIP. Customizing a super jumbo jet of this magnitude is mathematically unprecedented. Engineers essentially took a massive double-deck pressure vessel and totally reinvented its internal structural integrity from scratch. They turned a standard commercial airliner into a self-sustaining habitat cruising in the stratosphere.
Let's dissect this aerospace marvel, layer by layer. The aircraft was split into three distinct, highly customized structural zones. You've got the cargo hold down below, retrofitted for a garage and a luxury spa. Then moving up the main deck, which was transformed into a royal throne room. And finally, the upper deck, housing these incredibly advanced, tech-driven hologram rooms.
Section 1. Mind-blowing interior anatomy and engineering. Let's actually look at the physical problem-solving here.
Starting down in the cargo bay, engineers had to completely bypass standard loading ramps. They calculated a heavily reinforced load floor that could literally secure two multi-ton Rolls-Royce Phantoms. These vehicles had to be rigidly anchored so they wouldn't tear through the fuselage during the intense G-forces of takeoff, extreme banking, or severe turbulence. Wild stuff. Now, what's really interesting about this slide is 2 millimeters. That is the exact metric engineers used to solve a massive density problem. You see, putting a full Turkish hammam on board using solid rock, aerodynamically impossible. So they used advanced material science to slice real marble to an ultra-thin 2 millimeters, bonding it to super light, high-tensile carbon composites to maintain the structure. Because, as the saying goes, in aviation, weight is literally everything. For some context, commercial airlines have saved millions of dollars in fuel just by taking a single olive out of their salads. Every excess gram on this VIP jet directly degraded its lift-to-drag ratio. Engineers had to shave off weight at a microscopic level just to avoid aerodynamic failure, all while maintaining this perfect illusion of solid stone architecture. Moving up to the higher decks, we find an absolute marvel of avionics integration, a private prayer room using advanced holographic projection. This system was hardwired right into the aircraft's live telemetry and gyroscopic sensors. It was autonomously recalculating global coordinates at 900 kilometers per hour, instantly adjusting the projected prayer mats so they always pointed precisely toward Mecca, no matter the plane's pitch or yaw. And back in the tail section, a 10-person concert hall featuring a grand piano. Now, being sandwiched between 4 massive turbofan engines, the acoustic interference would normally be deafening. The fix was complete acoustic decoupling. Engineers actually suspended a secondary, frequency-attenuating isolation chamber inside the fuselage to totally block external engine vibration from penetrating the hull. Okay, back on the main deck, the absolute centerpiece was a continuously rotating gold-plated throne. Now, from a physics standpoint, putting a heavy, rotating metal object in the fuselage introduces dynamic angular momentum. This constant kinetic motion had to be perfectly calibrated because any uncalculated shift in mass could seriously disrupt the plane's delicate center of gravity during critical phases of flight.
Section 2. Aviation weight and aerodynamics. This is where the math gets really chaotic.
So, all these modifications yielded 550 square meters of usable space. That's a footprint bigger than a lot of luxury homes on the ground. Managing an area this huge in the stratosphere requires a staggering payload distribution matrix. You are essentially piloting a multi-deck building through the sky, and every single square meter is a potential critical failure point for the aircraft's balance.
And this brilliantly illustrates the sheer mechanical thrust needed to sustain all this. We're looking at a wingspan of nearly 80 meters, 4 massive turbofan engines, and despite all the extreme mass from acoustic chambers and reinforced marble floors, engineers achieved a mathematically verified max range of over 15,000 kilometers. It was fully capable of flying nonstop from Riyadh directly to New York.
But sustaining that flight relies on absolute mathematical symmetry. Engineers spent months, literally months, calculating complex moments of inertia. They had to ensure that this incredibly asymmetrical layout, like a massive car garage on the left and a reinforced marble bath on the right, would perfectly align the constantly shifting center of mass with the aerodynamic center of lift.
As the quote says, turning a massive A380 into a private jet really threw everything into chaos. The broader infrastructure of global aviation just wasn't ready for it. Standard VIP taxiways and private airport runways didn't have the physical width or the necessary pavement load classification, meaning the critical weight-bearing threshold to stop a localized jet of this insane density from literally sinking into the tarmac.
Section 3. Aviation History's Great Mystery. Let's move to and see how this builds, because this poses the ultimate statistical anomaly of the entire project. With $500 million burned and unparalleled aerospace engineering deployed globally, why did the prince never actually fly his own creation?
Well, the data shifts pretty dramatically in 2013. Before the highly complex interior payload could even be fully finalized and installed, a sudden, classified economic maneuver happened. In a completely unexpected move, the asset was quietly offloaded to an unnamed anonymous billionaire before its maiden voyage was ever completed.
It is the ultimate aerospace paradox, isn't it? Despite pushing Airbus engineering to its absolute theoretical limits and creating this huge media frenzy, the $500 million behemoth never flew over the skies of Riyadh sporting its intended gold-plated insignias. The custom blueprint was finalized, but the grand experiment was permanently aborted by its original creator.
So, the crucial point is, we are left studying the blueprints of an aerodynamic ghost ship. It forces this fascinating final analysis of extreme wealth colliding with rigid physics. Was engineering a 2mm marble hammam and real-time holographic telemetry on a commercial airliner a brilliant expansion of mechanical physics, or is it simply the most mathematically inefficient display of wealth ever conceived? Let me know your hypothesis. Thanks for joining me for this explainer, and I'll catch you next time.